Hello everyone. So this tutorial is about dynamic partial reconfiguration using uh, Vivado HLS generated IPs. Okay, so in this tutorial we are going to see how we will be doing this dynamic partial reconfiguration when our IPs are generated through the Vivado HLS. Now in this example we have we can say two partial configurable regions, one where we choose either the STA or the TRFI, which are two channel estimation techniques, and in the second one where we will be choosing two separate DNNs, whether the STA DNN multiple configurations, and here I am taking only two. So it would be either the STA DNN or the TRFI DNN. So let's move forward and see how to first generate these IPs. Now, as I said that this is for the normal Vivado HLS flow where we generate the IPs using the Vivado HLS. So we will proceed normally during with this. So we will first have all the source files here, and then after simulating and verifying the functionality, we will go for simulation, synthesis, co-simulation, and finally, this is where we need a little bit different approach. So while exporting the RTL, we won't be doing this IP catalog. We will synthesize checkpoint. So here, click for the synthesize checkpoint. This is OK, and click on OK. All right, and we will see that it will synthesize the checkpoint instead of creating an IP. It will create a synthesized checkpoint in as .dcp format, which we will be using during our DPR flow. Okay, so we have finished generating this checkpoint at .dcp file. You can see here in the solution one under the implementation IP, we have this statrfi.dc. All right. So yeah, one more thing we need to make sure is that all these IPs, for example, for the STA, for DCP, we need to have the same top module name. So that's why it's like STA TRFI for both STA as well as the TRFI. So we need to make sure for um, all of the checkpoints, all of the IPs that we are going to be using in this partial reconfiguration region, it needs to have the same top module name, right? So we can copy this DCP file and keep it somewhere we can use. All right. So we will generate all these DCP files, all the synthesized checkpoints using this HLS flow. So now, before we move on to create the Vivado block design and other things, so we will first, after generating these, we will first create a blanking configuration. All right, where there is like it will have a top module, but it doesn't contain anything within. To create a blanking, that black box configuration sort of everything. So we will first create a blanking configuration where we will be having only the top level module port definitions of like our STA, TRFI module and our DNN module. Uh, and it will be like a black box sort of a thing. So there will be nothing inside it, no logic, nothing, just the top level module. Okay, so we will be generating that. So for that, we will use this Vivado IP packager. All right, so let's see. Now, this is our STA module. So it's the same, like it has the same, all the input, output, everything. It is the same as the HLS generated one. So the top module definitions, the port definitions are all the same. It's just that it doesn't have any logic in it. All right. So first, it's a very important step, and we have to undo it. So yeah, right. We'll first create and package a new IP, right? Because we have to package it as an AXI stream, because that's what our module is. We have this AXI stream based these STAT, RFI, and DNN IP, so it also has to be this AXI stream based. So we'll create and package a new IP. Next, package your current project because that's what we have to package it. Next, it uses the location, so it would be in the imports DPR test, right? We'll look at it. All right, and finish. Now this is a very important step here. So we can see in the ports and interfaces we have few warnings, and we have to take care of it. All right, and this warning, if we see, it's related to these stream ports and the clock. Bus interface EST stream, okay, frequency it's okay. Bus interface APRSTN, polarity is exit flow. This is the most important thing. Bus interface AP clock, associated bus interface parameter is missing. So we will go to this AP clock one, all right, and go to this parameters, auto calculated, associated bus interface. We will edit. Okay, so now we have to list the list of bus interface names separated by colons. So this clock is associated with both the stream ports, EST stream and the in stream. So we will write both the ports here. So it will be in stream and then colon EST stream. All right. So because these are the access stream ports, we need to associate them with a clock, and we will do this. Okay. All right, and we see now there is this one, we can ignore it. So it's a bus interface API set, and okay, we can ignore it, and we can go to, yeah, review and package. All right, edit packaging settings, delete project of packaging. Now we can keep it like that. Okay. All right, now we can go with the package IP, and it has finished packaging this IP. All right, so our IP is ready, and we can use it in our design. Now the same, we have to do the same thing with the DNN one, because I said that here we have these two separate partial regions. We will be having two separate partial regions with two separate configurations. All right, so we have to do it for all these partial modules that we are going to create. So this is the blanking configuration for this STA TRFI, which will contain the STA partial region, which will contain the STA block and TRFI block. Okay, in a time multiplexed manner. Now we will do the same thing with this DNN one. So we have the same thing with this the DNN one. We have this only the top level ports here, and we can go with the create and package new IP. Next, the same package will come, and it has packaged. All right, so now all our prerequisites are completed. So we have generated all these IPs. So I have only shown you generating the IP for one of our configuration using the HLS, but I have actually generated these DCP files for like four of our modules that we have. I have four modules: STA TRFI, STA TRFI, STA DNN, and TRFI DNN. So I have generated the DCP files for all of these. Let me show you. Yeah, so I have generated these DCP files for all the modules. So I kept it in here, reconfig modules, so that it's easily accessible. And you can see in our first configurable region, we have the STA and TRFI, and it will have the same name. So in the DCP files would have the same name. All right, and in the second one, we will have the STA DNN, so it's the same name, and the TRFI DNN. Okay, so this is very important in here. So I've generated all these configurations, all these DCP files for all the modules that we need. I have generated this IP for as the blanking configuration. Now we can start with the Vivado flow of getting this dynamic partial reconfiguration, generating these partial bits and partial bit streams. All right, so we will start with creating a fresh new project. So let's give it a name, STA TRFI DNN DVR. Okay, next, select the board. This is the normal stuff that we do. Create block design. Okay, so I will create the block design and I will meet after that. Right, so we have created this block design, and the first thing to note here is that in the first, when we have to when we generate this first block design, we will use the blanking IPs that we created. Right, so we can go to the settings and add the IP repositories that we just created. Okay, the project 2, it has that DNN IP. You can see that, okay, it has one IP, which is this DNN top. All right, and we also have that project 1, we created it in here. Yeah, so it has that STA and TRFI IP. All right, so you can see STA TRFI. So these are those blanking IPs where we don't have any logic implemented. Right, and go OK, and we will use these two IPs in here. Right, the way we have connected them, the output of STA will go to the DNN, and the input will come from input. The in stream will come from the DMA. The outstream of the DNN will go back to DMA. Right, so you can have your own design the way you have the way for any application the way you want it. This is the way this design is uh, generated. So yeah, we can just it is the clock and reset. Yes, just go to the automation. That's okay. The clock and the clock. It will just connect the clocks. All right, so our block is ready. Let's validate it. See if there is any error or anything. Okay, yes. So if you had not created the blanking IPs using this the IP in packager the way I showed, you can see that if we had only used those .v files, the blank v files in here, the validation would not have been successful, right? It would have shown that the your stream ports is not connected to the any clock. All right, so make sure you go through the process of generating these blank IPs here. All right, so validation successful. Okay, we can just, all right, so we can save it. Okay, so this is done, and don't go for any synthesis or anything right now. So right now we are done with this. So let's first thing is we don't need to go to the entire bitstream one. We will just do it step by step. Okay, so yeah, let's first so I will be using this tickle commands here. So I will do everything using the tickle command. You can go through this the normal GUI one, run synthesis and everything, but we will have to use the tickle this here. Okay, we will have to use the tickle commands here. So first let's go with the synthesis one. Let's launch the synthesis. I will use the tickle commands to synthesize the design. All right, so we'll wait till this design is synthesized. Okay, so we forgot to have here the create HDL wrapper. We have to set a top module. Okay, so that's why there was this error. So now we have this one. All right, so let's go with the synthesis again. Okay, so after the synthesis is complete, you can just go for the cancel one. All right, so we will open this synthesized design. Yeah, it should be like this. So there are two warnings that we could not resolve non-primitive black box cell. All right, so we have two black box cells that blanking design that we created. So that's okay. Create. All right. And if we look at these under the design ones, okay, design wrapper, we had two blanking configurations, one at the DNN, right, DNN top, and one at the STA TRFI0. That's what the warning was, that there are two like black box cells which it cannot resolve. That's okay. So let's uh, let's save this checkpoint. Okay. This is the command, write checkpoint minus force. So if it's already there, so it will force it to overwrite, and in this folder. So enter. Okay, yeah. So I need to first go to this. All right, and now we can write this command. Earlier, because it was in the C1 where it normally opens, so we have to change to this, the folder where we have it now. Okay, so it's writing this, the checkpoint. All right, so we can now close the project. If we want, we can keep it like this, but let's. All right, so see, we just saved the checkpoint, right? So if we want to start from here, the reason we saved it is that if we do it right now till that point and we want to do it again afterwards, right? We can just open this checkpoint that we just saved, which has the blanking configuration there, right? So we open the checkpoint, give the same path as before, and it will open our this synthesized design. All right, the synthesis design is there, and we can see these black boxes. All right, so now what we are going to do is that in those black boxes, we are going to read the we are going to read the DCP files that we generated, the synthesized checkpoint. So for like this, the STATRF, our first configuration would be STA and STADNN, right? So in the STA, we will load sta.dcp file that we had generated using this HLS, and in this DNN top, we will use this STADNN.dcp file which we had generated using the HLS. All right, again, we will be using these tickle commands for it. So the command for it is, let's see, copy it here, just. All right, so read checkpoint, okay, minus cell, because we'll be reading this checkpoint in the cell, and the cell name is first it's the STATRFI, so its cell name, if we look from here, first we will go to this design underscore one underscore I, so it will be design underscore one underscore I. All right, then within this design we have st underscore trf underscore 0. All right, and within that we have this inst. All right, this is what we are going to replace, this instance. Okay, now we are going to replace it with the dcp file that we had generated. Okay, if we remember, it is we had saved it in this the sources one. So we'll see where it. Okay, so we had it in here in the under the reconfigurable modules. We have it. Okay, so first we will use this statrfi.dcp in here. This belongs to the sta module. So first we will create the configuration for sta module. So we're going to just add it here. So give its path. You can see here's the space. I just don't forget it. So first we will read checkpoint cell and give the cell name this and then the path of the DCP file. Right, enter, and we can see that now it will read that file in this. It will no longer be a black box. Okay, so it has loaded this STATRFI STA1 that generated checkpoint in here. We will do the same with this DNN one. All right, so we will read the checkpoint and load it. Read checkpoint cell design DNN blanking 0. All right, it's a DNN top, so I have to check. So 0 and then INST. All right, and we will load it with this STADNN. Right now we can see that this one it's also loaded with the synthesized checkpoint. All right, so after these are done, now once again a very important step that we must not forget is that we select it. All right, and then we go to these cell properties. Okay, the properties here, and we have to make this reconfigurable. Now these two, we have to tell the tool that these two instances, there's these two cells, they are reconfigurable. For that we need to add this property in here. So it's hd reconfigurable. All right, so if you see here hd reconfigurable, okay, so it came under this one and we tick it. Right, so now the tool knows that this partition, this module, this is to be used in this reconfigurable way. All right, and same we will do with this one. So we will first add the properties hd reconfigurable, add it here, it comes under this properties one, click it. All right, and we can see that these both are now become this reconfigure. Now the tool knows that these are the regions that are to be used in the in a reconfigurable way. So these will be reconfigured. All right. Now again we will do the same thing. We will write this checkpoint. All right. We will save. So at each step we will save. It's not necessary that you need to save it, but in case something else happened or there is some error or anything, we can start from this point. So let's save it. Okay, so the next step is floor planning. We told the tool that okay, these two regions, these two modules, these are the reconfigurable one. But for a reconfigurable, to make the hardware reconfigurable, we have to specify a region on the board actually, where which a part of this board will become reconfigurable. Okay, so let's start from the floor planning of this STATRFI1. So we'll right click on it, okay, and then go with the floor plan. The floor planning, we will draw this P block. Okay, draw P block. And okay, before that let me show you one thing. So when we clicked on it, so these are the cell properties. All right, and here we can see the statistics. It tells us how much resources are needed. And when we draw the P block actually tells us, okay, this is a region where this block is to be placed and routed and everything. All right. So that region should contain these resources, this much resources. Okay. So here, so I said that we go to floor planning, draw P block. Let's for now see. Okay, keep it like this. Okay, I think I have not selected it. Draw P block. Yeah, now it's so let me select these two regions. Yeah, it tells us okay, slices it in a DSP 72 BRAM. Okay, I think this should be enough. All right, it and we can see here that it tells us okay, yeah. So there is no red. Everything you can see this P block should contain, should be able to have all these resources. All right, so this looks fine. And now again, one very important thing we must not forget it is we go to the properties and select these two things: reset after reconfig and keep the snapping mode as on. It's very important steps. Don't forget it. All right. So we can see it comes here, and now we do the same thing with the other one. So we go to the floor planning, draw P block. I mean, this is a bit, it requires a bit more resources than the first one. So we'll select a bit bigger block. Right now I can go, okay, this should be able to contain, go to statistics. Yeah, it's able to contain all these. So now again, reset after reconfig and the snapping mode should be on. All right, here one more thing we can do is that we can see the reports. So we can report DRC. If there is some DRC error, okay, design rule check error, it should be able to tell us here. So we will uncheck everything here and only check the partial reconfiguration because that's the only thing we want, right? Click OK. So it will start the DRC check. No violations found. That means we are good to go. And that's it. We can save the design here. All right. So we can save this floor planning. We can save it in XTC file. So for that we can use this tickle command, write underscore XDC, then the path where we need to store it. Okay, so I have the sources folder in XDC where I keep it with the name this. All right, so enter. It's completed. It has saved it there. So next time if I want to make the same design with the same thing, so I can just use this floor planning here. All right, so we're done for now, as in we have all these like made the initial settings ready. So we have these partial blocks. All right, we assign these with the partially configurable regions. We had blanking configurations. Um, we have read these the original configurations, the STA and the STA DNN on them. Now we can go and we can go for the bitstream generation. All right, so we will go with the bitstream generation again. We'll use the tickle flow. The first thing it's like the op design, which will optimize our design. Enter. Let's see. Let's wait for it to end. It shouldn't take much time.